The phase of a wave refers to the angle of a point of that wave in regards to the cycle of a circle. One wavelength represents a complete cycle of a circle or 2 radians. Waves can be in or out of phase, and it is this phase value that determines if interference between 2 waves will be constructive or destructive. Wave superposition refers to the displacement caused by the interference of 2 colliding waves. Depending on whether it is constructive or destructive interference, the resultant wave will have an increased or decreased amplitude. If 2 peaks collide, then the resultant wave will be at its maximum amplitude. But if 2 waves meet and they are completely out of phase by 180 degrees, the resultant wave will have a 0 amplitude.
Spin it, man. Okay, this got to be the best wave check I done ever seen, man.
A stationary wave occurs where 2 consistent waves meet travelling in opposite directions. Because they are consistent, some areas along the wave will constantly meet so that they superimpose destructively. These points do not wove and have 0 amplitude. At other points, the wave will fluctuate between all amplitudes. This is an antinode. The number of nodes in antinodes are defined by the wavelength of the wave and the distance they travel. On a string, a standing wave will have a cycle that appears to be the same as any progressive wave. This means that if a string has a length L and there are 2 antinodes on it, the wavelength is equal to the length L. Specific names are given to each antinode added going up from 1, or the fundamental, up in overtones. Wave speed on a string is given by velocity equals square root of tension over mass per unit length. Frequency can then be rearranged for as frequency equals 1 over wavelength multiplied by the square root of tension over mass per unit length. Diffraction is the bending of waves around an object. The amount of diffraction of a wave depends on the wavelength of the waves and the size of the gap. A small gap blocks most of the wave energy, whereas for a large gap, only a limited amount of the wave is close enough to the gap to be affected. The optimal amount of diffraction occurs when the gap is the same size as the wavelength. Light through a narrow slit results in a diffraction pattern showing a central maximum bright spot surrounded by dark minimum points, followed by further maxima and minima. A diffraction grating takes this to the extreme by having many small slits that cause light to behave in a particular way, which allows the angle of a particular bright spot to be calculated with this formula. A standing wave could also be called an interference pattern. Interference patterns can also be created via 2 different sources. Any coherent waves that meet will superimpose, which in some areas will mean that there is a continuously no overall displacement minima point, and in other areas there will be greater displacement's maxima point. A double slit experiment is a classic example of this. Whether a point is maxima or minima depends on its distance to each source or its path difference. This is because the path difference will result in a difference in phases. If the paths differ by a whole number of wavelengths, then they will constructively interfere, producing a maxima. However, if they meet with a path difference of which includes a half wavelength, then they will destructively interfere to form a minimum.